Hey everybody, and welcome to another Jamovi tutorial. In this tutorial, we're going to be talking about point biserial correlations. Now, the interesting thing about point biserial correlations in Jamovi, as same as JASP, you don't really do much difference with doing a Pearson's R. It's actually the same situation, but of course, maybe you've got to do the point biserial. And so let's go ahead and figure this out. Well, first we need data. Okay, so let's go ahead and put in the data. The data that I'm going to be using is a sample of 36 men as 1, women as 2, and the ratings of whether they think sex is critical or not critical in a relationship on a rating scale from 1, not at all important, to 9, critically important. And they are from James McDougall's 2024 Mastering Statistics with JASP 2nd edition. So let's go ahead and put this into our data. Let's go to A here and type in gender. Oh, geez. I am struggling with that. Interestingly enough, let's go to B and let's type in rating, or what am eating, rating, and we're going to call this a continuous variable. It doesn't really matter if we call this continual or ordinal. I think continuous is going to be easy for us. Okay, and then we're just going to get rid of a variable C. All right, very good. No, I don't want, I don't want you edit. No, of course that's not variable. Die variable. I forgot that you have to go over here to delete it. Okay, there we go. Let's go back to data. Alrighty, let's grab these ratings. Yes. Let's go ahead and see. Let's go 2 by 36. Oop, too far. And there. So we have our gender and our rating. Now, what we're going to do is going to go to regression, go to correlation matrix, and we are going to put rating and gender into here. Now you can see that gender is a nominal variable, and over here it only accepts scale and ordinal, but I'm going to put them over anyways because I want to. And you can see that I just left Pearson selected. Oh boy. Why did I leave Pearson selected? Well, it's because if you put in a nominal variable, it treats it as a numerical variable and will run a point biserial correlation. Although this point biserial correlation isn't the exact value that you'll get if you run a specific point biserial correlation and a point biserial calculator. So really, this is trying to give us Pearson's R on a variable that can't have a Pearson's R. Let me show you if I put in correlation matrix here. We've got all of the dots for 1s and 2s, and then it's giving me this big negative slope. The value doesn't actually matter. It really depends on how the data was coded, right? It would be positive if I made 1s female or women and 2s men. Like it would be a positive 0.314, right? And so this p-value is telling us that there is a slight relationship, right? A slight relationship, maybe not enough in this case, between gender and ratings. Although we can see that men tend to rate the importance of sex higher in relationships than women do. There are lower values for this set of women than this set of men down here. And so point biserial has to be used when you are using nominal variables, whether we've got nominal variables and we're correlating nominal variables with nominal variables, or we're correlating nominal variables with ordinal or scale variables. We have to use point biserial. But it's hard-coded into Pearson and Jamovi, as well as JASP, that is what we're doing here. And so that's how you do a point biserial correlation in Jamovi. It's really relatively simple. The difference between point biserial and Pearson is the input variables, but you can use the same hypothesis testing rules for point biserial that you would use for Pearson, and you can square your point biserial correlation, and it represents the same shared variance between the two variables that R squared does when you square Pearson's R. So that's how you do point biserial correlations in Jamovi. If you have any comments, suggestions, feedback, please leave those in the comments down below. Thanks for watching. I'll see you in the next one. Bye.